We're starting a series of paper discussions that focus on learning from video. There's two aspects. So there's one is learning from video, existing videos. So let's say YouTube videos where you look at, let's say, how-to videos from humans. Doesn't have to be humans, but let's say humans. It could be animals or just how things are done. And then the next step, and that's the paper we want to discuss today, is actually from generated video. So we can have videos generated from in simulation, and then use those videos to train and then translate them from sim to real. So this paper, From Generated Video to Physically Plausible Robot Trajectories, links in the show notes, is a collaboration between Berkeley, New York University, and a couple of important researchers in that field. So what I find so interesting about this paper is that I think it's actually showing sort of on a big picture what the problem here is. So the problem with generated video is that you have a lot of, let's say, inconsistencies. Video generated, which is, let's say you take a human that runs and then you generate a video from the ground truth, and you generate many different trajectories of humans running. That human running will not be fully physically equivalent to a real human. There will be mistakes with, let's say, joint angles, and one leg will be maybe too far back versus the other. Like it just won't be as good as maybe a real human would be. Now, this can be solved with adjustment. So what this whole paper is about is really sort of transforming real human videos into generated videos at an unrealistic scale, and then closing the morphology gap, which is once you have a human generated moving realistically, you still have the gap between the human and the robot that you're trying to train. No matter what the robot looks like, it's not going to look like the human. So, and the key detail here is they're using key points. So they're not using, let's say, angles of your arms or joints in general. They're using key points, and those key points in relation to each other can correspond a real human, and therefore translate that to a real robot and keep it in latent space. So meaning in simulation. So this data then can be used to train on a generated video in reinforcement learning, generating many trajectories. Because the bottom line is that you want to create a lot of trajectories and therefore solve the out distribution problem. And then once you have trained the policy on, let's say, walking or doing stuff in a house and whatever it is, you then translate that from sim to real. Now, I think there's still the sort of seminal paper in this whole problem set, in my opinion, is still the drone flying paper by Scaramucci. But of course, this is now going into much deeper territory. This is going into real world interaction with the real world and the problem that these people are trying to solve. And one of the authors is Jan LeCun, and he obviously now has a world model company, because the problem that they're trying to solve is they're trying to solve the data scale problem. The same way language was solved with internet scale data, what they're trying to do is solve the same, use the same approach, basically apply the bitter lesson to robotics. But in order to apply the bitter lesson to robotics, you need to have data at scale, and you can have that with generated video. So this is I think this is the North Star. I don't know exactly where we stand. I hope CVPR this year can teach me, and this is going to be actually our focus this year at CVPR. So it's generated videos and then learning from generated videos for humanoid robots. That's the goal. That's the fundamental idea that we're trying to learn more about in CVPR. And then the corollaries to that are, of course, what does this mean for Tesla Optimus, and what does this mean for NVIDIA, are two big investments. I think for new listeners, maybe this podcast series, the purpose of the Not Even Wrong podcast is to give people a sense for what it feels like to run a hedge fund. So we're in the knowledge business, so we're going to have a lot of different types of approaches towards our end goal, which is generating wealth. And one of them is reading academic papers. Now that's of course a very dangerous endeavor, because you can spend your whole life reading academic papers, and science, it's like the famous line in Dr. Faust: the more I know, the less I know, or the more I read, the less I know. So you have to be very careful. You have to be very focused, and you have to, I think, be goal oriented here. What's my goal? My goal is how can I solve the data scale problem for humanoid robots? That's the goal, and then get the knowledge that academia can provide for this particular goal. And I think that's what we're doing here. So the paper's in the show notes. The technicalities are not important here for us. I think what we really care about here is that there's a path towards scaling data, and therefore a path towards robots actually taking advantage of the bitter lesson and learning how to move in the real world. And they can do that via generated worlds, and a transformation from the generated worlds onto the robot in latent space, and then using reinforcement learning at scale to then translate the parameters from sim to real, and then hopefully have a robot that can actually move in the real world. And it has been taught from world models. Thank you.